Hello gentlemen, welcome to our video today. Our objective today is to get practice with dimensional analysis problems. So the density of air at ordinary atmospheric pressure in 25 degrees Celsius is 1.19 grams per liter. What is the mass in kilograms of the air in a room that measures 14.5 feet by 16.5 feet by 8.0 feet? Now, to make our plan, we're looking at, what mass is needed. So we know that if we have mass and we're given a density and we have dimensional units for volume, we can use the density formula, where density equals mass over volume. We're looking for mass, so if we rearrange the equation, mass is volume times density. Well, we have a volume, essentially, and we have a density. So really we have to just multiply those two things. However, they're not in like units. We have feet, feet, and feet, which are going to give me cubic feet. And we want, when we multiply volume times density, we want the units to cancel. We want liters to cancel out, so we can just have the units of mass, and then we can convert this mass to kilograms. So we want to get cubic feet into liters so that the units can match. So we can have liters here for our volume, and it can match with the liters here. All right, so let's get on that. That was my plan. We want to find our volume first. So the 14, actually I'm not going to find the volume. I'm just going to use the volume. Get in the habit of doing that. So this is my volume. We have 14.5 feet by 16.5 feet by 8.0 feet. That is going to give me cubic feet. I'm not going to solve here. This is not a newbie lesson. We're going to keep on going. So we know that we have some quantity of cubic feet there, but we want to get it to liters. So let's make a pathway. I'm going to go from cubic feet to cubic inches to cubic centimeters to milliliters to liters. Now we've used most of those conversions before. So I want to go from cubic feet to cubic inches. I need feet down here, inches at the top. These are related. 12 inches for every 1 foot. But I want cubic feet, so I cube everything, not just my units. And now cubic feet cancels with feet, feet, feet. Okay, so now I want to get rid of cubic inches. Inches, I want to get rid of those, but I want to get to centimeters because of centimeters here. We have 2.54 centimeters for every 1 inch. But since I want cubic inches, I cube everything. Now I have cubic centimeters. Cubic centimeters is related to milliliters in that for every 1 cubic centimeter I have 1 milliliter. And here's where things start to equal out and you don't have to start cubing things anymore, because naturally this cubic unit here is equal to something that's not cubed, 1 milliliter. So those cancel out naturally. And now for milliliters, I want to go to liters. Every 1,000 milliliters equals 1 liter. Okay, so this, you don't have to draw this part, but technically that is your volume. You found the volume by multiplying the first two things, and you just converted it to liters. Now, as the plan suggests, we want volume times density. I'm not going to write times density here, but I will multiply times the density, which is 1.19 grams per liter. And liters cancel. In case you're wondering, that is nothing there except a little blotch. OK. My next step is to get grams into kilograms. This is essentially my density, and that's going to give you your mass. So for every 1,000 grams, I've got 1 kilogram. And that's it. When you simplify all of this, you get 64 kilograms. All right, so do this on your own and see if you get the same thing. Our next practice problem, and our final one. So find the inner diameter of the opening of a very thin cylindrical glass tube, given the following experimental information. The glass tube has a length of 24.53 millimeters. The mass of the glass tube is 3.258 grams. Excuse me. It is then filled with mercury, and the mass remeasured, it is found to be 3.446 grams. The density of mercury is 13.546 grams per cubic centimeter, and the volume of a cylinder equals pi r squared times the height. Okay, this is a challenging problem. Here we have to really think outside the box, and we're going to do this one in more of a stepwise fashion and not in one big step, simply because it's easier at this stage to break it down. Okay, so I'm going to draw, kind of, physics style, a little picture here. It's not quite a force body diagram or anything, but it may help. So we start with an empty cylinder on the left here, and its mass is 3.258 grams. It is then filled with mercury, and the mass is remeasured and found to be 3.446 grams. Now it says the length of the tube, which is going to be the height of the tube, of course, is 24.53, that's 3 millimeters. Now inside of here we have mercury. Mercury has a symbol of Hg. That's a symbol of mercury. Mercury's density, so density sub Hg, is 13.546, that's grams per cubic centimeter. Okay, so that's what we know so far. And we know the volume of the cylinder is pi r squared times the height. So now we have to figure out a plan. So in this kind of problem, I like to work backwards with my plan. So I know that I want to find the diameter. I'm not given anything about diameter here, but I do know that diameter is directly related to radius, right? So I know in order to find diameter, I need to come from the radius. And if this is helpful, I'll write the arrows the opposite way so you know we're going in a reverse design kind of way. We're starting from the answer and working our way back to see how to figure this out. The radius is found in this volume equation, so we need to find the volume along with the height. So we use volume and the height to find the radius. Well, the height's given, so check. We've got the height, but we don't have the volume. So this is the volume of the glass cylindrical tube. Well, since the glass cylindrical tube is filled with mercury, the volume of the tube equals the volume of the mercury, since the one is full, since it is full. So we can use information that we know about the mercury. But we know the density of the mercury, and through some subtraction here, in comparing these two, we can figure out the mass. So we can use the density and mass to figure out the volume. Okay, and we can do that with the equation volume is mass over density. Okay, so now let's get to it. So the first thing I'm going to need to do is figure out the mass. So I have the mass of these two different scenarios, but not the mass of the mercury itself, so I must take the difference of these two things. Okay, so here, the mass of the mercury, we take 3.446 grams, subtract from that 3.258 grams, and we get 0.188 grams. That's already rounded to the appropriate sig figs. So now we can take this value and excuse me, divide it by the density. But I'm going to do this dimensional analysis style. Okay, so I'm going to take it, and I'll go over here. So I'm going to take it 0.188 grams, and instead of dividing just like with a division sign under the 0.188 grams, I want to show the units canceling by just writing it like this. So the density is 13.546 grams per cubic centimeter. So that means that number, 13.546, is tied to grams. So since we want it to cancel grams, we put this at the bottom. Okay, and grams cancel. And essentially I'm just dividing by the density, as it's in the denominator here. Okay, and from there, I'm going to simplify. Even though I usually don't simplify early, I am now, just so that we can do this in bite-sized pieces. This is going to be your volume. And the units match for volume, cubic centimeters. So now we know that volume equals pi r squared times the height. Now I want to find radius. That's what I'm really concerned about. So radius squared equals v over pi times the height. And eventually, we'll take the square root, like so. Now what we have to keep in mind here are the units. The units for the height are millimeters. Units for the volume are in cubic centimeters down here. So they must be in generally the same units. So what I'm going to suggest is that we put millimeters into centimeters. You could put centimeters and millimeters. It wouldn't matter. Honestly, whatever you want to do. They don't specify what the inner diameter has to be in terms of what units. So you can do whatever units you want. But I'm going to go centimeters, okay? So I'm going to convert this up here. 24.53 millimeters. I want to convert that to centimeters and get rid of millimeters. So for every 10 millimeters, I have 1 centimeter. That gives me 2.453 centimeters. That's my new height in centimeters. Now I'm going to do that so that volume and height can actually interact mathematically with the appropriate units. Units matter, guys. They matter a lot. So I'm going to fill in the fraction here. But I'm going to do it, I'm going to fill this one in. I'll fill it in from the scratch, from the beginning. So we got 0.0139 cubic centimeters equals pi times r squared, which we don't know, times the height, which we know now is 2.453 centimeters. Okay, now getting r by itself, I'm going to skip this part in the middle, guys. So r equals the square root of 0.0139 cubic centimeters divided by pi times 2.453 centimeters. Here's where your units are really important, guys. This is why it was really important to convert this to centimeters. This cubic cancels with that and gives me a square. Taking the square root of a square gives you one dimensional, just centimeters. So it's important to recognize that. And if I do this, my radius equals 0.0424 centimeters. It's important that you abide by two things here. One, use all unrounded numbers. So use the unrounded number for this. And use the pi button on your calculator. Don't type in 3.14. Use the pi button. So find it and use it. And now this is in centimeters. That's perfectly fine. We know that diameter is 2 times the radius. So we do, say, diameter equals 2 times your radius. Now remember, use the unrounded version of 0.0424 centimeters. And our diameter equals 0.0849. All right, gentlemen, hopefully this helps. Take notes on this stuff. Adios.